Hello everyone and welcome to this video tutorials on MPI. I am Abdul Kadir Lamin and I will present you codes written in MPI to execute a program in a parallel environment. So first of all, I am using C in writing my MPI programs. So as you can see, first of all, I have included MPI-H library, .H library, and included stdio.h library. So message passing interface, it is a library used for parallel computers, clusters, and heterogeneous network. MPI provides a powerful, efficient, and portable way to express parallel programs. There are certain primitive functions used in MPI, such as MPI init, MPI com, and MPI com size, and MPI com rank, and finally MPI finalize. But there are also many other functions used by MPI. So within these videos you will come in contact with some of those functions and I will explain to you to them. Now let us get started. We have int main, int argc, character argv. So my argc is known as argument count, which contains the number of arguments passed out to the program, and my argv is known as argument vector, which is one-dimensional array like a vector, since we know that a vector is a one-dimensional array. So I will initialize MPI environment. This is the code. After then I will use wall size. This my wall size is just the size of the processes which will be created with the MPI command. So we have talked of MPI com size primitive. Its MPI com is like it contains all the communication. It is a primitive for communication. So MPI com size will contain the size of the process. MPI com world. MPI com world is a default communicator. It contains all the informations regarding to the default size. So this is my address for world size. After that we have MPI com rank. So it will use the rank of the processes. So after then we have print hello world process rank out of processors. Now at the end we have to finalize our MPI program. This is our first hello world program. So next on we have another exercise which is regarding to the multiplication of two matrices. Now here we have int argv and argc. As usual, we initialize our matrix A, matrix B, and matrix C, which will contain the result of multiplication. We have start time and end time. MPI init, as we saw earlier, MPI init to initialize the MPI environment. MPI com rank to contain the rank of each processor, and MPI size to contain the number of process which will be created. MPI status to know the status of each process. If my rank is equals to 0, so I am the master process. If my rank is equals to 0, I am the master, and then I will display all these informations. Matrix A, we take matrix A here, this is it, we multiply it with matrix B, which is here. Since we are working on a parallel program, so we have many processes which can perform a task at a given time. So we have to send messages to each process to receive a data and perform some calculation and send back to the data to the master process. We are using here broadcast metrics, broadcast MPI broadcast. So MPI broadcast matrix B ms time ms MPI int, so that we can have our values in integers. MPI com world, the default communicator. Since messages will be sent to the process, and the processor will also send back a message to the master process, this means that we have MPI send for sending information, data, and MPI receive for receiving the information, the data. At the end, we receive data. The master call, which is my rank is equals to 0, master receives the information and perform the last calculation, return back the answer, and we finalize our environment with MPI finalize. Move on to the last exercise. We have sum of first 5 integers. So we know that first 5 integers is from 0 to 5, or 0 to 1 to 6. So here we have our function which find the sum. Here is our main program. In our main program, we define numbers to be 5. I'm working with 1 to 6. Int rank, sum, max, and my first number. So first call MPI init, we initialize our MPI environment. Get my MPI rank. This MPI rank, we will get our rank through this default communicator MPI com world. Here we perform our sum and we finalize the environment. Now, after seeing the programs, let us go to executing and compiling and executing our programs. Let's save. That's good. Now we are on Ubuntu Linux. We will use our terminal to compile and execute our programs. Facilitate our work. So we have to, I am listing the program to see the exact names of our programs to be executed. Let us start with our hello world. Hello world.c. So we will put MPI CC, which stand for MPI compiler. So we will take the name hello. I'm having many programs named hello world, so I have to be careful to know which one to compile. Hello world.c, hello world. Now we will give a name for the file to save after compiling. So here we are putting MPI hello world. The compilation process went successfully. Now MPI run space MPI hello world. Sorry, I have not yet started the lamb boot. Lamb boot is okay, and compile back hello world. As you can see, hello world from processor Abeka is the name 0 out of processor 1. This is since I'm working on dual core, I have 2 answers. Let us move forward and compile another program. Multiplication of 2 matrices. You have matrix multi exercise 2. Now MPI dot matrix multi Excel. Oh, there is an error in writing the name, so I have to be very careful. Exercise 2.c. Matrix MPI. It went successfully. Now we have to run our matrix MPI. So we have parallel visit processing matrix multiplication by my name, University of Ngaoundéré, matrix A, matrix B, matrix B by process 0. So this is our result, matrix C. So we have 2 processes which carried on. Like we are working on dual core, I have explained, like I've explained earlier, we are working on dual core. So I have 2 answers. You see, parallel time took 0.00 second. That means it took less than a second to perform the matrix calculation multiplication. Now let us see our last but not the least program. Sum of 5. sum mpi. I think we have sum mpi. I think we have nothing named like this. Okay, I think it will give. The compilation went successfully. Now we want to run our. Remember that we are running the sum of 0 to 5, which will give us sum mpi 15. So I will present you some other functions used in MPI to define process and to define number of process you want and the rest. Like you can see here, I can run my hello world program but with 4 processes that I can define with the function np number of processes. As you can see, we have 4. So thank you for watching this video. Please subscribe and share.